Hello and welcome back to the lab. So today we're finally back to working on the HP339A distortion measurement set. Um, when we left off, we had set it up so that the output of the oscillator section was looped back and connected directly into the input of the distortion analyzer section with a 600 ohm termination. And the meter works, but when we switch to distortion and try to make a distortion measurement reading, we have two issues. Um, First of all, the frequency indicator light does not go out, and that means that the oscillator frequency and the notch filter frequency are not the same, or at least the instrument thinks that they're not the same. And that should never happen because they are directly connected from the output of the oscillator directly to the input of the distortion analyzer. The second issue, which I believe is really the same issue, is that the null does not go deeply enough. We're measuring a distortion reading on the meter of about minus 80, looks like minus 88 dB below the carrier, below the fundamental. It really should be about 10 dB better than that, um, or even more than 10 dB better than that. Um, so the null is not going deeply enough. So let me show you what I've worked on so far and what we found so far, and where we're going to decide to go from here. Okay, so we're looking at the schematic for the A4 assembly, and when I was operating the 339, I noticed that U1 on the A4 assembly, U1, which is this op amp here, was very warm to the touch, and that seemed unusual. So I ordered a replacement for U1, a direct exact Hewlett Packard part number OEM replacement, and I did swap out that U1, and it turns out that the new one that I put in was equally warm to the touch. So I assumed that maybe there's something else in the circuit that's causing that to happen, or perhaps it's normal. I wasn't really sure. When I made some measurements, all the voltages and so forth, and signal levels seemed to be appropriate everywhere in that circuit, in that area of the circuit. So I started looking around in other areas of the circuit on the A4 board. I did some testing, and I saw that this capacitor here, C25, that is a 650 microfarad capacitor, tantalum capacitor in the feedback loop of this integrator circuit here around U5B. Um, it had a small amount of leakage, so I couldn't find a direct tantalum capacitor replacement for that cap. But what I did find was a pair of a pair of 330 microfarad standard electrolytics, and I replaced that capacitor with this pair of 330 microfarad caps in parallel to give 660 microfarad, which is close enough to 650. And the same problem still existed. So that cap probably was just fine in actuality. Um, so I decided I'm not having any luck with trying to troubleshoot this board. So what I did was I went and purchased an entire replacement A4 assembly and dropped that into the 339A. And lo and behold, the same problem still exists. There was actually never anything wrong with the A4 assembly. I spent hours and hours working on this board when the problem doesn't even exist on this board. The problem is elsewhere in the instrument. So that's where we are now. So here you can see the new A4 assembly has been inserted into the instrument, and this is the A4 that was being used at the beginning of this video when we saw the symptoms still existing. It already has the replacement A4 assembly. And when you touch this U1 op amp, it also feels warm to the touch. So it's completely normal for that op amp to be warm, as it turns out. Um, I didn't realize that at the time. Um, the problem is not on this board. The problem must therefore be on the motherboard, somewhere on the motherboard. Um, I don't think the problem is anywhere inside the oscillator cage, inside the shielded part of the instrument, because the oscillator appears to be working just fine. But something in the automatic null circuitry of this main board back here, it's got to be the problem. So let's take another look at that circuit in the schematic. Okay, so here we're looking at part of the A3 assembly, which is the motherboard for this instrument. It's got to be where the problem is located, somewhere on this page of the schematic. Um, there is no problem with the automatic gain control or the amplitude control part of the circuit. So this feedback loop is working properly. The amplitude control lights extinguish when they should be and come on when they should be. So all of this circuitry is working properly. That adjusts the gain of this op amp here through this opto coupler over here. So all of that circuitry seems to be working properly, but the frequency control is not working properly, and that is controlled through the feedback from the A4 over here, driving this opto coupler over here, which adjusts the phase control of the notch filter. So we have a phase shift amplifier U1 on the A3 assembly. Something may be going on with that, something maybe with this optocoupler, or there may be something else in the amplifier circuitry here that appears to be frequency related, not amplitude related. This also passes on through um, attenuators and another amplifier, and the distortion output goes out here. It's going to be hard to troubleshoot. I think what I might want to do is try to just shotgun it and replace perhaps this U1 op amp. Maybe take a look at this opto coupler, and maybe that's the problem. It is a photoresistor and a photodiode and an LED that provides feedback to adjust the automatic frequency control for the notch filter. If this is not working properly, that might be our whole problem. Although it seems like it's almost working. That's why it's going to be difficult to troubleshoot, because the entire instrument is almost working properly. Okay, so let me show you what I did. I broke down, and not only did I purchase an A4 assembly, I also purchased an A3 assembly. So here is a spare motherboard that I can use as a parts unit, um, to borrow parts off this board to solder into the defective motherboard until we find the problem. I won't even really have to troubleshoot. I'll just start swapping parts out. That might be the way to go, because this problem is very subtle and close to meeting spec, but not quite. So I think what I want to do is replace that opto coupler first. Um, there's one here. I don't know if this is the amplitude one or the phase control one. I'm not sure. And there's another over here. One of those two might be the problem on the motherboard. So I'll start by figuring out which one is the phase control optocoupler, and I will swap that out and see if that solves the problem. Okay, so I have removed the optocoupler in question. HP calls this E1, and it is the phase control optocoupler. It's got two sides. There's an LED side, so that's polarized with a plus and minus connection, and those plus and minuses are labeled on the motherboard. And the other side is the photoresistor side of the optocoupler. Now, by the way, this troubleshooting technique that I'm using to do this, sometimes called the shotgun technique, where you just scatter randomly around, replacing things until the problem goes away. Um, Sometimes we call it the swag technique, scientific wild ass guess. Um, but that's what I'm doing. That's what I've come to, the swag technique. I've already put too much time and too much money into the repair of this instrument. I just want to get it done. So when I pulled this one out, this optocoupler out of the motherboard, which is down here, you probably can't see it. Underneath it, I found some kind of a residue of a substance. It appears that it was one of those contact cleaner type deals that had lubricant in it. So there was like an oily residue underneath it. And that may have been causing some kind of leakage. I don't really know. I'm just, swagging right now. I'm just swagging. One thing I wanted to tell you, if you're going to work on these instruments, on the A4 assembly, we have these yellow board extractor levers. When you're flipping the instrument upside down, these board extractor levers flip up. And if you slide it around, you can very easily snap these yellow levers off, which is something you don't really want to do. Trust me, I've already done it, and that's why I know. This is the new board. It has the levers are still intact. But on the old board, if you can take a look, I'll show you. Those levers have broken off the board because of just that. When I flipped it over upside down, these levers flipped up, and then when I flipped it back over, they snapped off. So please be aware of that and be very careful when you're flipping this instrument over from top to bottom to do work on the boards. All right, so let's replace this um, optocoupler with the one from the motherboard that I purchased as a parts donor. And we'll see if maybe it solves the problem. So I pulled the E1 optocoupler out of the donor parts board and soldered it into the A3 motherboard of this instrument. It was difficult to do because it's pretty deep down in there, um, but I got it in. Let's see if it works. All right, I flipped the unit over and I got it on the universal tilt stand here, and I plugged it in. Let's turn it on. Okay, the instrument is reading really close to full scale because we've got 3 volts going into it at 1 kilohertz. Switch to distortion mode. One thing I noticed right away, the frequency indicator lights have been extinguished. The frequency of the oscillator and the frequency of the notch filter is the same. Look how low the meter is now. It's reading about negative 93 right off the meter. That's not even looking at the output through a spectrum analyzer. Reading at negative 93. It's been improved by 8 dB, and it hasn't even been readjusted yet. I think we fixed it. I can't believe I can't believe it's working. Let's try some different frequencies. The frequency light stays on. I mean off. The frequency light stays off. The notch goes down on all the frequencies. Appears to be working on every frequency range. Wow. I have fixed the problem already. I can't believe it. I can't believe it. It's working. Wow. So it was that opto isolator, that optocoupler E1 on the A3 assembly. I didn't really need to purchase a whole new A4 assembly or a whole new A3 assembly, but it's probably the only way for me to get a hold of one of those optocouplers anyway. But that was the problem. It's fixed. So let me go through and realign it, and I'll bring you back when that's been done, and we'll take a look at the output on the spectrum analyzer and see what this thing is really capable of doing now. All right, so after readjusting everything and putting the covers back on this instrument, let's see what we have. We're set to 1 kilohertz. Our input level, we're measuring on the 3-volt range. We've got a full scale indication, 3.16, whatever that is, volts. All right, we are in a 600 ohm termination from the output to the input. Let's switch to distortion mode. Reading off the meter on the front panel, we have negative 92. Negative 92. Not sure what the spec is off the meter, but that seems pretty good to me. Let's take a look at what the spectrum analyzer shows. All right, so I've connected the monitor output of the 339A into the 1 megohm input of my 3585A spectrum analyzer. And we are set on the 339A, we're set to 1 kilohertz. We're measuring the input level right now. I've set the offset so that our reference level is at 0 dB at the fundamental frequency. And when I switch to distortion mode, we will measure the notch depth of the automatic notch filter on the 339A. Now the 339A distortion range is set to minus 80. So we take our measurement here and we add 80 dB to it, or subtract 80 dB. So we have minus 80 plus a minus 44, let's say 44, 45. That's negative 125 decibels. The notch filter goes down about 125 dB below the fundamental. That's pretty low. That's pretty low. Um, we were measuring before something like 86 to 90 dB. Now we see 125. That is way, way, way better than the minimum specified for this instrument. We have indeed repaired it. All right. So now let's take a look at the harmonics, the second, third, and fourth harmonic, to see what the distortion is coming out of the oscillator. Okay, so we have a fundamental notch reduction of about 122 dB, it looks like. Let's step up the center frequency to look at each of the harmonics, to take a look at what the total harmonic distortion is coming out of the oscillator, or whatever distortion is generated internally by the 339A. So we step up to the second harmonic. It's minus 90, minus 17, also minus 80, so that would be negative 97. Third harmonic, negative 102. Fourth harmonic, negative 102. Fifth harmonic, negative 104. Sixth harmonic, negative 108. Seventh harmonic, negative 109. Eighth harmonic, negative 112. Ninth harmonic, negative 114. 10th harmonic, negative 118. So our total harmonic distortion is something like negative 90. What did we have here? 97, negative 97. And the specification is 85. I believe it's 85. Let me see. Here's a manual. Oscillator distortion at 1 kilohertz should be 95, negative 95 dB. And we are reading negative 107. No, we're reading negative 97. So it is within spec. All right, we have fixed this instrument. So what have we learned? Well, I learned that sometimes the swag technique of electronics repair is the best technique. Just take a wild guess and replace what you think might be the problem. Turns out to be the best solution in this case, at least. All right, so that will do it for the 339A distortion measurement set repair. Thank you very much for watching. Please like and subscribe, and stay tuned for more fun videos with vintage electronics equipment. Thanks again.